This video is designed to help you adopt unified core features in Lightstep, including our unified telemetry dashboards, notebooks, alerts, and change intelligence. If you're watching this video, you may be familiar with some of our legacy features, including Explorer, RCA, and the Streams Tri-Charts view, which are being removed from our product later this year. Not to worry though, our team has been working diligently to ensure the workflows you rely on can be easily migrated to our new unified core features. In just a moment, we'll walk through the most used workflows from Explorer, RCA, and Streams Tri-Charts and show you how to achieve equal or better outcomes by using our unified core features. These workflows include writing expressive span queries, viewing latency, throughput, and error rate over time, generating custom service diagrams, identifying correlations from attributes and operations across the stack, and configuring alerts using span data. But first, let's start by walking through the specific features you'll be using in place of Explorer, RCA, and Streams Tri-Charts. We've built a new set of query interfaces which allow you to explore both span and metric data in a single unified interface. These interfaces are available across Lightstep and can be used to build rich dashboards, collaborate in notebooks, or define proactive alerts. We've even made them available in our APIs. Regardless of which interface you choose, you'll be able to query across the last 3 days of span data by default with the ability to define retained span queries, previously known as streams, right from the query UI. You'll also have access to a rich set of visualizations, many of which feature embedded span exemplars. The Unified Query Builder, or UQB, offers an intuitive and familiar GUI-based interface, while our Unified Query Language, or UQL, provides power users with more complex functions to write expressive queries. Though our query interface is consistent across our unified core features, we've designed dashboards, notebooks, and alerts to enable specific workflows for our users. Dashboards is intended to be your monitoring hub, where teams can build rich dashboards with beautiful charts to track their business, infrastructure, service, and transaction health. Our Terraform integration makes it easy to deploy standardized dashboards across the entire enterprise for faster MTTR, reduced maintenance burden, and improved governance. Where dashboards offer a standardized destination for specific monitoring tasks, Notebooks is designed to enable collaborative ad hoc investigations. You can easily create a notebook from nearly any page across Lightstep and work with your team to collect and annotate charts in a kind of living document. When you're done, you can save the contents of a notebook for durable storage using snapshots. Finally, our unified telemetry alerts give teams the power to create SLIs for their infrastructure, service, and transaction health using either span or metric data. Alerts come bundled with important context to help users expedite triaging and also enable an important bridge between Lightstep and other platforms, including ServiceNow, Slack, and PagerDuty. Sitting on top of our unified core features is Change Intelligence, our always-on, cross-stack correlation engine, powered by distributed tracing. Change Intelligence is accessible from any chart across Lightstep, including span and metric charts. Once you identify a change you're interested in exploring, you can simply click the chart, select Analyze Deviation, and confirm your baseline and deviation windows. Then, Lightstep will get to work searching across your stack to find the operations and attributes that are statistically correlated to the change you're investigating. Each finding can be easily added to a notebook for further investigation or used in a dashboard or alert condition. Now that we've explored each of our unified core features, we can walk through each updated workflow so that you feel comfortable migrating from Explorer, RCA, and Streams Tri-Charts. Let's start with writing expressive span queries using UQB and UQL. You might be familiar with Explorer's query interface, which allows you to select any combination of service, operation, and span attribute. Once you've run your query, you can see a list of spans from the last hour, which you can then filter or group. We've made this both easier and more powerful with our unified query interfaces, which I'll show you now. Please note, I'll be using notebooks for this example since it's a great place to do ad hoc exploration and investigation, much like the Legacy Explorer feature. That said, you can also apply this example in our unified telemetry dashboards and alerts. Clicking on the Notebooks tab on the left will bring me to an empty notebook. From here, I can simply start searching for the services, operation, attributes, or even metrics that I might be interested in. But for now, I'll replicate the same query that we just saw in Explorer. Now, I can easily switch between viewing latency, throughput, span count, and error rate, and even group the resulting charts using any of the attribution on our spans. Looking at the resulting chart beneath the query, you'll find far more options for visualization, including line charts, heat maps, and dependency maps. If you query for metric data, which was unavailable in Explorer, you'll also see area charts, bar charts, and big numbers. Beneath the chart, you'll find a table including the resulting time series and group by information, as well as a list of span samples. These span exemplars are also available within the chart and can be easily turned on or off depending on the visualization you're interested in. If I'd like to write a more expressive query, I can also quickly switch to the editor mode to access the unified query language. And finally, if I want to share this chart with others, I can simply add this chart to a dashboard, create an alert, or give the notebook a name, which will turn on auto-saving. This means I can quickly share the notebook link with others so they can collaborate with me in real time. I can also share a read-only snapshot of this notebook. This is useful if you want to ensure your span charts are retained past the standard 3-day recall window. Speaking of recall, let's talk about one of the major improvements in these new core features, retention. In Explorer, users had access to 1 hour's worth of span data they could query. Now, using our unified query interfaces, users can access a minimum of 3 days worth of span data. However, there are many scenarios where a user might want to look past their default 3-day retention period. As a note, we do offer additional days of retention as a paid add-on in our unified core features. But there's another tool you might be familiar with called Streams, which enables you to view trends in your span data over time. In Explorer, you could create a stream directly from your query and view them in a feature called the try chart, which combines latency, throughput, and error rate into a single chart. Streams are still an important part of our platform, but they're now more tightly integrated into the experiences where you want longer attention, namely dashboards and alerts. As a part of our migration, we're now calling streams retained span queries, and I'll show you how they work. I've created a dashboard to show you how to create a retained span query, identify if one is present for a given query, and also show you what behavior to expect in the event you try to pick a time window where a retained span query doesn't exist. Let's look at the time picker. As you can see, we're viewing the last 60 minutes worth of data, but let's go back to looking at the last week. Now, in the 2 charts visible, you see a bit different behavior between them. If we open up no retained span query, you'll notice that about half of the chart here is grayed out. And if I hover over, it's telling me that there's no data beyond the 3-day retention window. If we open up our query, we can find why. Our query is looking for a particular service and every customer that is not customer HipCore. In the bottom right of the Unified Query Builder, you'll notice that no matching stream was found for this query. Now, I could quickly add this and create a stream, and I can do this as well when I'm creating a query or a chart for the first time. Doing so will create a retained span query in Lightstep's backend, and from that point forward, we will retain SLI information and span exemplars durably for up to 2 years. If we move over into our other chart where a retained span query was present, you'll see that we have data going back as long as that retained span query existed. Opening the query shows us that the query predicate, in this case a more simple query looking just at a particular service, does indeed match a stream. With unified telemetry alerts, Any time you use span latency, throughput, count, or error rate will automatically create a retained span query behind the scenes. No action required. A popular feature in both Explorer and RCA are our service and operation diagrams. In Explorer, users could quickly turn any query into a custom service diagram featuring critical path latency and errors derived from thousands of underlying traces. In RCA, which was only accessible through Service Directory, users could view an operation-level dependency diagram that also included either critical path latency or error rate. In our unified core workflows, service diagrams and operation diagrams are combined into one. We call these dependency charts, and they're incredibly easy to use. In this example, we're looking at a unified telemetry dashboard with a mix of different visualizations on the page. Let's open one of the existing dependency charts. In this case, opening our query shows us that we're looking at the product catalog service and showing all of its dependencies at an operation level. From here, we see a chart that shows us the critical path latency contribution for these services. If I'd like, I can also switch from an operation view into a services view. I can also switch from showing all dependencies to just my upstream or downstream dependencies, or my immediate dependencies, which will show me only the dependencies within one hop up or downstream. This is a great way to make sense of the dependencies that rely on me or who I rely on without having to show my entire cloud native estate. Another improvement with our new dependency diagrams is how easy they are to leverage when you're already looking at an existing query. Let's expand this PCS latency chart. Looking at the query, you can see that we're only looking at the latency for this product catalog service, and I do see a spike that I might be interested in. I could zoom in to this spike, and from here I can change my visualization, perhaps to a heat map first to show population distribution, or switching into a dependency map so that I can quickly see how latency or errors are propagated both upstream and downstream from the product catalog service. And of course, because this is a unified chart, it's easy for me to add to a notebook and share with others. Next up, let's look at how to generate cross-stack latency correlations using change intelligence and, optionally, metrics data. Users coming from Explorer will recognize the correlations table on the right. The correlations table allowed you in a powerful way to search for particular behavior in the histogram above your span table and compare the traces within that latency window to those outside of it. Lightstep would analyze those traces and find the operations or attributes that were statistically correlated with the behavior you were investigating. Users familiar with RCA might recognize our one-click analysis feature to analyze performance, where you could select a baseline and regression window and allow Lightstep to perform a similar type of analysis, finding the attributes and operations that changed between the baseline and deviation window. With our new unified core features, we've made this easier and more powerful than ever. Now, from any chart in Lightstep, users can simply find a change that they're interested in understanding, click the chart, and select Analyze Deviation. From there, Change Intelligence, our always-on correlations engine, will pop over the right side of your screen and allow you to refine your baseline and deviation windows. Then, we'll assemble traces to find the cross-stack attributes and operations that are statistically correlated with the change that you're investigating. I can click on any of these suggested hypotheses to explore them further, and I can also open up the full change intelligence and provide me with a more expansive interface through which I can do my investigations. Let's walk through the information that change intelligence is presenting to me in this example. Starting at the top, we can expand our baseline and our deviation windows, or view the query that was powering the original chart. In this case, we're looking at a metric query for latency in milliseconds filtered to a particular service, the warehouse service. and looking at the sum of all values. Beneath this chart, I can see all of the changes that Lightstep has identified in the service associated with this query, the warehouse service. Now, even though we started on the warehouse service, many of the changes that Lightstep has identified did not take place in the warehouse service, and in fact seem related to the iOS service, which is a few services upstream from the service that we queried. I'm opening up this customer probable attribute, which Lightstep is suggesting has a high correlation to the change that I'm investigating. I can see that during the baseline window, the customer probable was responsible for about 8.6% of our traces. During the deviation window, that rose up to 43.7%. I can see this behavior as well in the SLI charts provided. I can look at other customers, maybe those who are not pro-wool, and I can even group by customer to see each individual customer's experience. On these charts are span exemplars, allowing me to quickly access the underlying traces so that I could explore single transactions, and also an easy way to share this hypothesis or add a particular chart to a notebook for further investigation. I can provide feedback on if this particular hypothesis was useful to me or not, which will improve Change Intelligence's algorithms moving forward. Finally, let's look at how you can use unified telemetry alerts to generate latency, throughput, and error notifications using span-derived SLIs. With unified telemetry alerts, we've made it easier than ever to add alerts from anywhere across Lightstep. Here, we're looking at a unified telemetry dashboard with a number of charts containing both metric and span data. Regardless of the underlying data, I can simply choose the chart where I'd like to create an alert and select Create an Alert. That will copy the query from that chart into our new alert template. In this case, it's asking me to provide some additional information to finalize the creation of this alert, including a latency input window, a percentile, a critical or warning threshold, and a notification destination. Here's what this might look like, completely filled out. As you can see, I provided an input window of 30 seconds. This means that Lightstep will be constantly analyzing latency over a 30-second interval, looking at the 95th percentile. Over that window, if we open the alert configuration, we'll see that we are looking at latency above 140 milliseconds and issuing a critical alert. This alert can go multiple places. For this example, we've not selected a notification destination, but you can use ServiceNow, Slack, PagerDuty, and many others, including generic webhooks. Scrolling down a bit further, you'll see an analysis looking at the last 60 minutes of data to give you an idea for if a particular signal would have triggered an alert threshold based on recent behavior. Finally, you can find all alerts for your project under the Alerts tab on the left. From here, you can create new notification destinations, create new alerts using either metric or span data, and leverage our out-of-the-box alert templates to help you with creating some more complex alert conditions for your organization. We hope that you are as excited as we are about these upcoming changes to our product. Of course, if you have any questions at all, your customer success team is standing by, ready to help. Please feel free to reach out if you have any questions, comments, concerns, or unbridled enthusiasm. Thanks for watching.